The field of engineering is aeronautical engineering, which incorporates the aspects of dynamics, electrics, mechanics, and structural engineering. Engineering specialization for this group is the takeoff run of an aircraft. The topic of mathematics applicable to this field of engineering, covered in our course, Maths 142, is differential equations. Differential equations are used in systems which involve variables proportional to each other. In these equations, calculations involve taking derivatives of different variables, allowing for values to be found in order to understand the forces that affect the takeoff of an aircraft. In the case of an aircraft, to calculate its variables, second-order differential equations are used.
In engineering, it's integral that one's prediction stays true. In this industry, engineers hold a great responsibility as lives ride upon their predictions, meaning unexpected results hold great consequences. Predicting the length of a runway needed for an aircraft to take off is a big deal and vital to the safety of passengers. During the early stages of flight, runways commonly consisted of a clearly grassy, relatively flat field. As technological advancements progressed and airstrips became more crowded, takeoff runs deteriorated at a faster rate, giving rise to more permanent solutions which cost money. Through engineers being able to predict the distance required for flight, runways became shorter, saving money and increasing safety standards.
To calculate a safe takeoff run, engineers had to create a precise model representing a takeoff of an aircraft. This model combines all components leading to an enabling flight. Force relations shared between the aircraft and its surroundings were gathered. Mass of aircraft reacting with gravity, reaction force with contact point to ground, aerodynamic lift, thrust force from engine, aerodynamic drag inhibiting thrust force to a degree, resistance with ground contact. Zero vertical acceleration produces the equation of motion. The horizontal equation of motion, with S being distance travelled along an airstrip and T being time that a point is.
Aerodynamic lift and drag forces vary throughout this procedure, gathered from experimental analysis. Due to this, engineers calculate these forces as proportional to velocity squared,
creating assumptions to be incorporated into equations of motion. Now it is possible to substitute our assumptions into both the vertical equation of motion and the horizontal equation of motion, eliminating G and vertical equation becoming. Now the vertical and horizontal equations can be equated, and V can be replaced with ds dt.
Assuming thrust is constant, we are left with our final differential equation with respect to the first and second derivatives of time of the distance travelled by the aircraft. Being a differential equation expressed as the distance s travelled along a runway, us as engineers can now use this model to calculate the distance for the aircraft's lift to equal its weight as it hits flight speed.
Source acknowledgements. Acting credits. Thanks for listening.
Hope you've enjoyed
Our presentation.